If you've ever looked up at the night sky with a sense of wonder, you've likely felt the pull of the cosmos. For decades, that journey was defined by giants, machines of unimaginable power that roared to life and briefly touched the void. We remember them with reverence. NASA's mighty Saturn V, standing a colossal 111 meters, 363 feet, was the undisputed king. With a staggering 35,100 kilonewtons, 7.6 million pounds force of thrust, it threw open the doors to the moon, launching payloads of up to 140 metric tons to low Earth orbit, LEO. It was and remains the benchmark of an era. In the years that followed, other titans took to the skies. United Launch Alliance's ULA, Delta IV Heavy, a true workhorse at 72 meters, 235 feet, reliably lofted the nation's most critical satellites with its 9,900 kilonewtons of thrust, carrying nearly 29 tons to LEO. Then, SpaceX itself changed the game with the Falcon Heavy. At 70 meters, 229 feet, its trio of Falcon 9 cores generates a thunderous 22,800 kilonewtons, 5.1 million pounds force of thrust, enabling it to deliver nearly 64 tons to orbit while landing its boosters. A facet once considered science fiction. These rockets are legends. They built our modern world in space. And yet, as we stand on the cusp of a new age, their incredible achievements are about to be eclipsed. Enter Starship, the current generation vehicle, V2/V3, a gleaming stainless steel behemoth, stands 121 meters, 397 feet, tall atop its super heavy booster. When its 33 Raptor engines ignite, they unleash a mind-bending 74,000 kilonewtons, 16.7 million pounds force of thrust, more than double the Saturn V. It's designed to lift over 150 tons to orbit and return to Earth to do it all over again, perhaps on the same day. Those numbers are already hard to comprehend. But what if I told you this was just the beginning? What if the rocket currently flying is merely a stepping stone to something far, far grander? Elon Musk announced on X that sent ripples through the entire space community. It wasn't a flashy presentation, just a simple text post outlining the future. And in it, he revealed the next true giant. Starship V4 will have 42 engines when 3 more Raptors are added to a significantly longer ship. That will fly in 2027. Starship V3 is a massive upgrade from the current V2 and should be through production and testing by end of year. Musk's tweet wasn't just about the monstrous V4. It laid out a clear, iterative development path, a hallmark of SpaceX's philosophy. Think of it as a 3-act play. Act 1. Starship V2 is the pathfinder, the pioneer. These are the ships and boosters we've been watching fly, test, and yes, sometimes fail spectacularly. Their mission is to gather data, prove the core concepts like the hot staging maneuver and re-entry, and pave the way for what's next. Act 2. Starship V3 is the workhorse in waiting. Described as a massive upgrade, V3 is all about production efficiency, reliability, and performance enhancements. It's the version intended for a high flight cadence, the one that will likely begin deploying Starlink V2 satellites and demonstrate orbital refueling. Act 3. Starship V4 is the headliner, the showstopper. This is the vehicle designed not just for orbit, but for the Moon and Mars. It represents the culmination of all the lessons learned from its predecessors, scaled up to an almost unimaginable degree. Let's talk numbers, because V4 statistics are simply breathtaking. The full stack will stand 142 meters, 466 feet, tall. That's nearly 20 meters taller than the current Starship and makes it taller than a 46-story building. The Super Heavy booster will grow by 10 meters, and the Starship upper stage will stretch by about 8.9 meters. This increase in size translates directly into a massive leap in capability. The payload to low Earth orbit is projected to be over 200 metric tons in a fully reusable configuration. To put that into perspective, you could launch the equivalent of an entire International Space Station module a large communications satellite, and a crewed capsule in a single flight, with capacity to spare. This isn't just an incremental improvement. It's a paradigm shift in what's possible. So, why just make it longer? The answer lies in one of the most fundamental principles of rocketry, the Tsiolkovsky rocket equation. In the world of spaceflight, there's a sacred formula that governs how much a rocket can change its velocity. It's delta V. One of its most critical variables is the mass ratio, the ratio of the rocket's fully fueled mass to its empty mass. By stretching the tanks, SpaceX dramatically increases the amount of liquid methane and oxygen propellant Starship V4 can carry. While this adds some structural weight, the increase in fuel far outstrips the increase in dry mass. The result is a much healthier mass ratio, which means more delta V. That extra delta V is what enables heavier payload. The tweet also revealed a crucial detail. The total engine count will rise to 42. With the Super Heavy booster already maxed out at 33 engines, this means the Starship upper stage will gain 3 more, going from 6 engines to 9. And 3 new engines will almost certainly be Raptor vacuum engines. This is where SpaceX's engineering prowess shines. It's a tale of 2 engines designed for 2 very different jobs. Efficiency is king. The role of the Raptor vacuum, RVAC. An RVAC engine is a specialist. It features an enormous bell-shaped nozzle designed to be as efficient as possible in the airless vacuum of space. This efficiency is measured by specific impulse, ISP, which is essentially a rocket engine's miles per gallon. The higher the ISP, the more thrust you get for every kilogram of fuel burned per second. For long-duration voyages to Mars that last for months, every single drop of propellant counts. By adding more RVACs, Starship V4 can perform its orbital maneuvers and interplanetary burns with incredible efficiency, allowing it to carry more cargo or complete the journey faster. The unsung heroes, the sea-level Raptors. Amidst the 6 RVACs, Starship V4 will retain its 3 central, sea-level optimized Raptor engines. While less efficient in a vacuum, these engines are absolutely vital. Their smaller nozzles are designed to perform optimally in the thick atmosphere of Earth or Mars. They are the engines that will perform the final, daring landing burn, providing powerful and precise thrust vector control to guide a skyscraper-sized vehicle to a gentle touchdown. This combination represents the perfect engineering trade-off: specialization where it matters most, and versatility where it's needed for survival. A 142-meter rocket doesn't just appear. It requires an equally colossal infrastructure on the ground, and scaling up presents a monumental engineering challenge for the team at Starbase Texas. The launch tower and Mechazilla, the iconic launch and catch tower with its giant robotic arms, is precisely calibrated for the current Starship. A Super Heavy booster that's 10 meters taller will require the connection points and catch arms to be significantly repositioned, or perhaps even a complete redesign of the upper portion of the tower. The high bay. Assembling a rocket of this scale requires a factory of corresponding height. Fortunately, SpaceX has always thought ahead. The construction of new, taller megabays or gigabays at Starbase seems to have anticipated this very need, ensuring they have the vertical real estate to build these future titans. Aerodynamics. A longer, heavier rocket behaves very differently as it slices through the atmosphere. The forces during max Q, the point of maximum aerodynamic pressure, will be immense. The profile for re-entry will also change, demanding countless hours of computational fluid dynamics simulations and testing to ensure the vehicle remains stable during its fiery descent. It's important to remember that this is a roadmap, a glimpse into a future set for 2027. But if there is one thing we have learned from watching SpaceX, it's that their philosophy of rapid, iterative development, building, flying, learning, and improving, turns ambitious roadmaps into reality faster than anyone thinks possible. Starship V4 is more than just a bigger rocket. It represents a maturation of a revolutionary idea. It's a testament to a relentless ambition that sees a 121-meter reusable rocket not as an end goal, but as a rough draft. It is the physical manifestation of the dream that drives every weld, every line of code, and every test flight at Starbase. This is the ship that will build the first city on Mars. This is the vehicle that will carry the hopes and dreams of a species eager to reach for the stars. And for those of us who have been watching this incredible journey unfold, it's a profound reminder that the age of giants is not over. It's just getting started.